So this lesson is really looking at introducing the sine law or the sine rule and the cosine rule. And if we look at this, both of these can be applied to non-right triangles. And so we see here we have a triangle that's not a right triangle, and we're being asked to find angle D, which is right here, and side FE in this triangle shown. All right. Of the two laws or properties, rules, whatever you want to call it, the sine law, I think is a little bit more elegant to start with. And so in general, if you're not sure what to try, well, try the sine law. And in general, the sine of any angle, in this case, D, we're trying to figure it out, divided by the side across from it or opposite to it, which is what we're trying to find out here, FE, is equal to any other pair of angles like that. For example, the sine of 124 degrees divided by 7. The sine of any angle divided by the side across from it. And my other combination I could look at is this angle up here. I don't know what angle F is, so I can say the sine of F divided by 6. And so all of these ratios I have here are equivalent to one another. Right now, I don't have enough information to figure out D or FE right away. I do have enough information to figure out angle F right away, so I'm going to focus on this pair of ratios right here and solve for angle F. And so whether you're cross-multiplying or whatnot, I can quickly get this down to the sine of F equals 6 times the sine of 124 degrees over 7, which means the sine of F, not F itself, is approximately 0.7106 when you go to a calculator. Keep in mind, with trigonometry and anytime you're finding sine, cosine, or tangent of various angles, very, very often you get these irrational decimals that actually go on forever without any pattern, as irrational numbers do. And so in general, try to avoid rounding much until the very end. In fact, on my calculator, I wouldn't use 0.7106, I'd use the answer that's already on my screen, which has more decimal places. But if that's a sine of F, then F will be approximately the same as the inverse sine of that decimal, 0.7106. But again, on my calculator, I would actually use the inverse sine of my answer that I have sitting on the screen to be as accurate as possible. Otherwise, this little bit of rounding error can really build up from step to step. And so we get angle F being approximately 45.3 degrees. Well, if that angle up here is 45.3 degrees, approximately at least, well, then we can use some old school, middle school, elementary school math to figure out angle D, because remember that all interior angles of any triangle always add up to 180 degrees. So this plus this plus this must equal 180, and therefore angle D I can quickly find by going 180 degrees minus those angles. So minus the 124 degrees we were given in the first place, minus the 45.3 degrees, or even better, minus what I have in my calculator, and we get something that I'll round to 10.7 degrees. All right, and so that's angle D. Now I want to find side FE, which if I look back to my original proportion, I now know angle D right there is 10.7 degrees. So now I can focus on this proportion, for example, because I now know the measure of angle D. So I can now say the sine of D, or in this case now, the sine of 10.7 degrees over side FE, which we've been trying to figure out. Must be the same as, I'll go back to that proportion I used from the start, the sine of 124 degrees over 7. And again, at this point, we can get FE pretty quickly by cross-multiplying, or again, whichever algebraic method makes you happy. 7 times the sine of 10.7 degrees divided by the sine of 124 degrees. Be careful with your calculator, and you should get about 1.6 centimeters if I round to the nearest tenth. Remember, especially questions like this that are multi-step trigonometric questions, it's so important. However much you are intended to round your final answer to have your previous steps have far more detail. And as much as possible, use the answers on your calculator to avoid needlessly building up this rounding error. Okay, for this triangle, I have all three sides. I don't know any angles, though. And I want to find the angle ABC, which means the angle from A to B to C. So that's this angle right here. Also, I can just call it angle B in this case. And so anytime you want to find the angle of a triangle and you know all the sides, we can use the cosine law, which is a little less elegant. And if I look up here for the cosine law, it is really comes back to the Pythagorean theorem, connecting it with the sine law, or is using the trigonometry. But instead of going through the proof of it, I'm just going to use that. Keep in mind what this is really telling you is that if you want to find the square of any side, it's equal to the sum of the other two sides when you square them, minus 2 times AB cos C. So AB are just the other two sides, and this C here is the angle opposite from the side we're trying to figure out. It looks quite messy and maybe a bit daunting the first few times you've used it. It's actually quite easy to work with once you've used it a few times. So let me kind of write this down first. And I'm just going to write down the exact version that I have in the sort of formula notes there. So C squared equals A squared plus B squared minus 2AB times the cos of C. I don't want to get hung up on the variables here. The key is, again, realizing whatever side I have here should have this angle C opposite from it. Now, in this case, I'm trying to find angle B, so I'm going to think of that as being my C. Or in this case, again, I don't want us ever to get too hung up on the letters A, B, and C. In this case, if I'm trying to find angle B, then my equation is going to start with 16 squared, because that's the side I know that's opposite from the angle we're trying to figure out, equals A and B are just the other two sides. Doesn't matter the order. We write them down. So I'll go 22 squared plus 18 squared minus 2 times those same two sides. We're multiplying, so the order doesn't matter. 22 and 18 times the cosine of, well, we're trying to figure it out. I'll put a B here. So notice the angle we're trying to find and the side that's isolated on the other side, or isolated and squared, those are how those sides always match up. And these sides here, the 22 and the 18, doesn't matter what order I write them. So now I want to solve for B. So the first thing I like to do is solve for the cosine of B, which means I'm going to take this 16 squared and subtract 22 squared and subtract 18 squared from it. And then divide by this minus 2 times 22 times 18 to isolate the cosine of B. And keep in mind, all of this will tell me the cosine of B, not actual B. Be careful with your calculator. If you want to do this all in one step, be pretty good with your fractions and watch all those negatives. You should get the cosine of B equaling approximately 0.696969 and so on. And this is where some inappropriate boys like to laugh at this number. Ha ha ha. Look at that number. And then that said, that's the cosine of B, not actual B. So B is approximately the inverse sine of this same ratio, which again, I would just use on my calculator screen, inverse sine of my answer, and you should get about 45.8 degrees when we round to 1 decimal place. Now, before I go on to the last question, you can see you are given in your IB formula booklet this variation of the cosine law, which is just the angle C isolated. And it's always true, but really at the same time, I'm not sure if that is really easier than just taking the basic cosine law formula and you working with it. Either way, last question, I got this quadrilateral ABCD, and I want to find the area of it. And conveniently enough, it's kind of been broken up into 2 triangles. And so like we saw before, if we could find the area of a triangle, which we most definitely can, we can find the area of this quadrilateral. Quite similar to a question from our last lesson. So first though, if I look here, the triangle I've highlighted in yellow, or triangle ABD, I can right away find the area of that. Because if you want to find the area of any triangle, if you know 2 sides that are adjacent to one another as well as the angle in between, this will always work. So the area will equal 1/2 AB, or in this case, 4 times 3 times the sine of the angle, 56 degrees. And from the last lesson, we saw this. Really what we're doing is we're finding the height of the triangle and multiplying by the base and dividing by 2 all together. And so all of that there, I can do quite quickly on any scientific calculator, and I should get about 4.9742 square centimeters. Now, notice I'm keeping a fair amount of decimal places there because I want my final answer to be accurate to 1 decimal place. So I'm giving myself more than enough room here to avoid having any rounding error kind of building up. Now for the second triangle, one in blue, I don't have enough information to do that right away. If I knew this side, BD, then I could do the same thing. I don't know it, at least yet, but I can figure it out. And I can figure it out using the cosine law, looking at the yellow triangle again. So I can figure out side BD by looking at the triangle in yellow and saying that side BD, well, actually, first I'll write down the general form of the cosine law. So c squared equals a squared plus b squared minus blah, 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 blah. Again, not getting hung up on the variables a, b, and c. The side we're trying to find, this side BD, that's the side I'm trying to figure out. Notice I know this angle opposite from it, and I know the other two sides, so I have everything I need. So I can say c squared, or even better, I'll say BD squared equals 4 squared plus 3 squared minus 2 times 4 times 3 times the cosine of 56 degrees. And so with this, we get side BD squared. I'll just skip the step. You don't need to watch me do all this. When I calculate all this and then square root it, I get BD equals approximately 11.579 centimeters. So keep in mind, that is taking everything here, calculating it, and keep in mind what I get is that side squared, so I got to square root it to find the side I want. And now that I know that side there is about 11.579, I can now use, again, this nice formula we saw from the last lesson about how the area of any triangle is 1/2 AB times the sine of A. And so in this case, I can say, looking at what's in blue, the area of that triangle will be 1/2 times the two sides of that. So I have, oh, silly me. I don't even understand my own writing here. I could go back and edit this video, but I'm far too lazy. So that 11.579 centimeters, sorry, that is actually BD squared. And so BD is the square root of that, which is about 3.402. Bad me. All right, and so now the area of that other triangle is 1/2 that side, 3.402, or even better, the number that's on my calculator, times the other side, 3 times the sine of 63 degrees. Because keep in mind, everything I have there now matches up with that triangle in blue. Because remember, that side BD we've now figured out to be about 3.402 centimeters. And so that should be quite quick to calculate. And we get about 4.5479 centimeters squared. That's the area of the triangle I've highlighted in blue. Up there in yellow, you can see the triangle I've highlighted in yellow. So altogether, this quadrilateral is just those two added up. And you add those two up, rounding to 1 decimal, you get about total area of about, drum roll please, 9.5 square centimeters.